Okay, here we are back again with our graph for Eddie Chow's baseline data. And I thought I'd point out these are z-scores. And so the difference between this bottom part right here, which is about minus 0.5, and this upper part, which is a plus 0.7, means that the effect size for the difference between spherical poor control and good control is about 1.3 standard deviations. That's a really big difference. This one for KT is a difference of about 0.3 and 0.2, about a half a standard deviation difference. So those are big differences between the two. And but what would be good is if we could see if they are significant. And one of the ways we can do this is by creating error bars. Now, not just any old error bars, but we want to create some special error bars. If you will recall from chapter 2, I believe, a 95% confidence interval has if the bars do not overlap, the difference is p less than 0.01. So let's do that. Let's create a 95% confidence interval. To do that, first we want to determine what is so remember, a confidence interval is the mean plus or minus some value, a t value, for the 95% confidence interval times the standard error. So our mean, or our width of our confidence interval, and one thing I'm going to point out, our confidence interval is going to run off the means of each one. So we really don't want to put in the 95% confidence interval starting with the mean plus or minus something. We just want to know the interval. And so first we'll find the t value for 95%, and this function t inverse with a 95%, but we're really going to do 0.05 probability, and the degrees of freedom are that n minus 1. So there are degrees of freedom. And if this was a z-score, do you remember what that value would be? It would be about 1.96. So we have a lot of subjects not altering things too much there. Now our standard error is, if you'll recall the standard error, it is the standard deviation divided by the square root of n. And the confidence interval, just the interval itself from the mean out to the n, is the t times the standard error. And then we want this guy, which is real nice because I just copied the stuff we're not doing for the correct, but that's okay. Well, let's go all the way down here, because this is going to calculate the confidence interval for the z-scores as well as that. Let me just make sure I have everything right. Yep. Okay, and then let's copy this. Paste it here. Paste it here. And so we're only concerned about the confidence intervals for the z-scores. So what we have, so now we have the confidence intervals calculated for each of the different groups. We're going to see we do this with quite a bit of difference when we get into t-tests and analysis of variance. But for now, this will work for us. So let's go to our, let's click on our graph, go to Design, add a chart element, error bars. Now, we don't want to use any of these. We want to go down to more error bar options. We're going to work with the aspheric first. We're going to go to Custom. We're going to specify our values. It's shaded here, so we're just going to come over here and start with the Z-score for age. And go down there. Those are our positive error bars. I'm going to come down here, and it's the same one, because in this case they're symmetrical. Now if we took logs, we'd have to do them separately, but we didn't, so there we go. And there's the 95% confidence interval for aspheric. Now let's do the same thing here. Add a chart element, error bars, more options, custom, specify value. The positive values are here. The negative values are here. I'm pretty sure I just did the wrong ones. Let's come back up here and try again. Oh, that was right. This was wrong. So we want the same ones going down. Okay. Now, non-overlapping error bars are significantly different. It looks like we have a significant difference on baseline on at least spherical equivalent between spheric poor control and good control. Like I said, I'm pretty sure I have these backwards, but it's okay for now. Okay, let's look at the other one. And what do we have here? We want to go to Design, add a chart element, error bars, more error bar options. Well, I'm pretty sure, I don't know why that did that. Add a chart element, error bars, more error bar options, custom, specify values. I'm going to come down here and do this, the upper, this for the lower, okay. And now we look. Now you can see there's no difference in anybody for age. There is no difference between the aspheric and either the and the control, this control group, this control group. But there is a difference between those two. And the difference is p less than 0.01, because these are 95% confidence intervals. Now that's p less than 0.01. What if we want to do p less than 0.05? That seems to be the more popular kind of thing. Let us copy our chart. Copy it down here. And remember the Goldilocks rule from the other day? So if we want 0.05, the standard error is too hot, the confidence interval is too cold, and the 84th percentile is just right. So the 84th percentile, gotta give ourselves a little space here. Probably wouldn't be that much. Now notice that the labels have carried over. If I had not put in this cell when I copied, I would just get series 1, 2, and 3. So, that's a little tip to keep things going. Okay, now what we want to do is we want to have 84% confidence interval. And so our t equals t inverse. The probability 1 minus, we did for 95%, we did 5%. 1 minus 95 is 0.05. For 84, 1 minus 84 is 0.16. And the degrees of freedom are still the same, n minus 1. And so our 84% confidence interval is equal to our t-value times our standard error. It's 0.12. Notice our confidence interval is smaller, 0.12 versus 0.17. Confidence, our interval is smaller, but we're not as confident about where the true mean is. Copy that down. Copy that. Paste. Paste. There we go. All right, unfortunately, we have, so the difference now is our error bars are no longer correct. So let's go into that and specify the value. And this one is this. Down is this. Okay. Let's go to the next one. Specify value. The upper. This is where you find out if you made a mistake before. Okay. And one more. Oops, wrong one. Hey. Oh, bummer. Okay, so we go to design, add a chart element, error bars, more options, specify values. Okay, and it's given us that. We want to go here. Click here. We want to go here. All right, so now we're at 0.05. So this chart gives us differences at 0.01, and this chart gives us differences at 0.05. Let's see if we can find somebody who is kind of close up here, but who's not significant. Oh, we don't have a good one. Well, let's take HVID. Notice how close they are right there. Now let's come down to HVID here. You can see they're a little bit further apart. So P less than 0.05 isn't quite as rigid. So they're not as close. So that's how you add error bars, and specifically 95% and 84%. We're going to be looking at how you calculate these error bars using the different methods. Here in this one, each particular group and variable had their own confidence interval. We'll see how that's going to change. We'll also see how the whole thing changes a little bit as we look at t-tests and analysis of variance. So that's it.